This kind of led to, at 21, I started getting some of these songs on the radio, and I ended up signing a record contract with Universal Music Island Records. This was, to me, one of the most exciting periods of life, because I thought I finally found the thing that I can survive doing. And I was still going through like very severe depressions where, you really couldn't leave the house or function at all. And I used to have this really troubling feeling that like if I just jumped off this balcony, all this would go away. If I'm just going to be like this, I have to try everything possible. Something has really changed in my mind here. I was looking at the window and I felt clear and calm, and I was looking at the window and enjoying nature. Glutamate accounts for about 80% of what your brain energy is being utilized for. Glutamate is not just a neurotransmitter, it's also a fuel source in the brain. Went on a ketogenic diet after trying like 30, 40 different treatments around the US healthcare system. Some of the people that remain on the diet find this to be a really life-changing intervention. I actually ran into one of them on the bus the other day, and it was really wonderful. He was just like glowing, like really enjoying his life.
Why don't you just break down your trial? Tell us what you saw. Take us there. Hi everyone, I'm really excited about today's show. It's deeply personal to me, to my family, and I think it applies to so many of you out there, maybe in a way that you don't even yet understand. We're going to talk to Dr. Ian Campbell. He has a PhD in global health from the University of Edinburgh and a principal investigator. He'd already completed a pilot trial on the ketogenic diet for bipolar. We're going to talk about metabolic psychiatry and how what we're eating and our insulin resistance, how it impacts mood and bipolar disorder, and his own incredibly empowering story of going from someone who has bipolar to a principal, like to a researcher studying bipolar. And it's just amazing to me. So welcome to the show. I want you to take us back to that moment before you had found metabolic psychiatry. What were your symptoms like? When did they begin? And what was a day in your life kind of like? Can you paint us a picture?
Yeah, thank you for having me on. It's great to be here. Before I was a scientist, I was managing sort of living with bipolar disorder type 2. And this is the one where you get sort of 80% depression, and then you get periods of kind of mania, hypomania. And I always joke it's like, the bad sequel to Bipolar 1. It's like Bipolar 2 is like even worse sometimes, because you just get lots of depression and no kind of upswings. And so I was trying to find ways to live with this and have a kind of semi-normal life. I first experienced symptoms when I was quite young, but I didn't really fully understand it was bipolar until much later in life. But I would go through these kind of depressions and what I now understand as hypomanias at that time. And the only thing that would really work for me was working in like creative arts, because you could make creative projects when you were high, and they would sustain you for like, the rest of the year when you were depressed. You didn't have to necessarily be constantly productive. You could create a good song, for example, and you could live off the royalties from that. So when I was, I guess I was about 20, and I started working at the BBC, which is the kind of like a TV station over here. And then during that time, I started writing music, mostly about my experience. I was always talking about kind of neurotransmitters in my songs. One of my songs was called Oxytocin, about the neurotransmitter in the brain, which it seems like a preposterous idea for a song title. But I would write about why I thought, neurotransmitters didn't really explain our full experience as humans. And around sort of just a bit before this time, my mother had a very severe brain aneurysm, and she lost all of her function and was in a coma for quite a long time. I was going through this in high school, and it was very confusing because I was very close with my family, and we completely lost her for quite a long time. And then when she did come back, her personality had really changed, and she sometimes didn't remember us when she was coming out of it, things like this. I guess it was like a sort of early, like one of these traumatic experiences that takes you a long time to process. And the way I tried to figure it out was through reading about science. I would go into the hospital and read books about what was happening to her, and I tried to understand why she could be such a different person. Like if you live with someone your whole life who's important to you, and then they just change into a completely different person, it's really hard you can't really grieve because you're still with the person, but you can't really fully accept that they might be completely different to the person you knew before. And it made me ask all these philosophical questions about what are humans? Are we just a bunch of chemicals that if they get disrupted, or if there's an injury to our brain, our whole person that we are completely changes? That question was like really stuck with me. I wanted to understand it. And so one of the ways I kind of tried to explore it was through music, and I wrote this song called Oxytocin, which is actually about what happened to my mother, and saying, is like, are different emotions just chemicals in the brain? It doesn't seem like that's all there is. There's something more to being a human than just sort of neurotransmitters and chemicals swishing around in your brain. So this kind of led to, at 21, I started getting some of these songs on the radio in the UK, and like on the kind of national radio stations. And I ended up signing a record contract with Universal Music Island Records when I was 21 years old. That was like a real fortunate thing to happen for me because I was really struggling to work and be consistently productive at work, and I would have periods where I just couldn't function, was in depression. Then I'd have like kind of super productive periods when I was hypomanic. And so I signed to this, I was this act called Keto Drift. You might not want to Google it. Some of the songs are better than others at that time. I was going through a lot of stuff. But I was this act on Universal Music Island Records, and we actually got signed by the president of Universal Music, Darkest Beast at the time, and he was incredibly sort of supportive and was quite helpful to us. In I think it must have been tricky because I wasn't able to function for quite long periods of time, like maybe like 2 or 3 months at a time with depression, and then I'd be very productive in writing songs, and then I'd go back into depression. But I could be well just enough to kind of sustain a living, and I was able to bring some of my friends into this act, and we would play we played like Glastonbury and the BBC Electric Proms, and like it was a really exciting time of life. But I was just really finding it hard to enjoy it because I was so unwell. But it was just basically the only way I could survive. So I thought I'll keep going with this. And eventually I got really into film music because I saw that all my friends who were film composers could just sit in a studio and write music and never have to go out and perform anything. Really, they could just kind of manage their own time. They could be productive when they could be. And I thought, this is the life for me. I want to do that. And so I applied to become the assistant to a film composer, and I became the assistant to Harry Gregson Williams, who was one of Hans Zimmer's composers. And I worked with him on his sabbatical when he was in England for a year, and we lived out in the countryside, and I just got married at the time. And this was, to me, one of the most exciting periods of life, because I thought I finally found the thing that I can survive doing. And I was still going through like very severe depressions where you really couldn't leave the house or function at all. But I could kind of push myself somehow in this environment because it was so fast-paced and energetic and exciting. And Harry actually asked me to move out to Los Angeles with him at the end of the year and become his writing assistant, which was kind of my dream at the time. I went out for some weeks too, and I just realised that I was very unwell. I ended up in a car crash when I was out, and so I realised when I was out in Los Angeles I was becoming much more unwell, and it was really just something I needed to take some time to deal with. And so I went back to the UK, and I was living in this small village with my wife where the studio had been based I was working at, and I literally for 2 months could not leave the house. I had sort of this catatonic depression it's really a blur, but for 2 months I was literally in bed, like I could not function, had constant kind of like very difficult thoughts. My wife was very worried about me at the time, and so we decided we had to like try and have a period of getting well. And so I went back up to Scotland from where I lived, and it was a time that was like, I just felt that everything that I'd worked towards has fallen to pieces. I've really reached a kind of all the things I would like to do with my life or contribute in the world are not going to be possible. I've just kind of collapsed into this like completely a very dark place, and we're living on a kind of 5th floor flat at the time. And I used to have this really troubling feeling that like if I just jumped off this balcony, all this would go away, all these problems, all this would no longer be able to affect me anymore. And I would really fight these thoughts, and I would have to try to distract myself and not go through it. And I knew at some part I would never do it, but they would keep coming to me of like how much easier it would be just to not exist. And I felt, you feel like you're kind of a burden to your family, to your wife. And I really wanted to have kids, was one of my kind of life goals, and this just seemed like completely impossible at the time. So I decided, okay, right, if I'm just going to be like this, I have to try everything possible, and if it doesn't work, then it doesn't work. But I have to first of all try everything I can possibly do. So I went on my Google Docs, and I made this sheet, and I called it like fight. That was because that was my intention, was just to like fight through every possible thing. And so I just made a list of everything I could imagine that might work. I started reading books and started reading blogs, listening to podcasts, and I wrote down everything that I thought could possibly help. And one of those was just to lose weight. I was very overweight at the time. I just had no conception this could have any effect on mental health, but I just put it as something that I could do to improve my life. Maybe it would help. And I started doing this kind of form of an Atkins diet. I'd just been reading online, and I saw that people with this thing called a new Atkins diet were losing lots of weight. So I thought, okay, I'll try that. And I got the book, and I didn't know at the time this is kind of a form of a ketogenic diet. It's essentially a ketogenic diet, but like a milder form of it. And I started doing this, and I remember sitting on the bus going to work one day, and I thought, like, something has really changed in my mind here. I was looking at the window, and I felt clear and calm, and I was looking at the window and enjoying nature, and I thought, I've never understood like that nature feels like this, that looking at nature gives you this beautiful experience of feeling calm and peaceful and happy. And I thought, people must experience this all the time. You know, this must be what it feels like, maybe, I don't know, to be normal. And it was almost like these kind of ripples of positive emotion would go through my brain that I hadn't experienced in such a long time. And at first I was completely confused about what was happening. I wondered, am I becoming manic, or but it didn't feel like that. It felt completely different and calm and stable. And this kept happening over many weeks, and I started trying to understand what was happening. My father was a medical doctor, and I said to him, this is the first time in my life I'm experiencing periods of wellness and feeling normal. And he was saying, well, what's changed? And I didn't really tie it to the diet at that point. I was thinking through everything, and I was like, it's really hard to say, but I am doing this diet and I'm losing quite a bit of weight. So I started reading about the diet, just trying to understand more about it. And then I came to learn that it was a form of ketogenic diet. Essentially, it puts you into ketosis. And then I started reading it, well, what is ketogenic diet? And I learned that it was a treatment for epilepsy that's been around for 100 years. It's got like over 13 clinical randomized controlled trials showing its efficacy in epilepsy. And I thought, that is interesting, because a lot of the treatments that we use for bipolar are epilepsy treatments, so like lamotrigine, valproate, carbamazepine. And I thought, maybe there's some connection here. This is a neurological treatment for epilepsy that's really effective, and I have a condition that's treated by epilepsy medications. So I thought, maybe this is something, and I started to research it. And the other thing that happened is I got my energy back, and for the first time I was able to think and be creative again. And so all I knew how to do at the time was to write music, and I also read papers all the time because of learning about health. So I just started doing both those things all the time, writing music and reading papers. And I had my first kid with my wife, which was amazing, because this didn't seem like it was going to be at all possible. And it was really kind of exciting to think, I could actually be a father and sustain a family and look after them and provide for them. It was really something that it just didn't seem possible for me not so long before that. And I started going back into music, and I ended up working at a company in Edinburgh called Rockstar Games, who make this game called Grand Theft Auto. It's a sort of computer game. It was the local. And I just worked a few days a week there when I could, and I started going back to university to study about global health and metabolism, and what I might do to kind of do some more in-depth research. And so I was researching, and I was working at Rockstar, and then after a couple of years I became the music producer for Rockstar, and we were working on this project Red Dead Redemption 2, which was a really exciting thing. And in the evenings I was working on research, and so it was just a totally weird path to becoming an academic. I didn't really intend it, if I wasn't like planning it at all. I just sort of was spending so much time reading that I naturally got interested in it. And then I met my father and I started publishing papers together, and we met Professor Daniel Smith, who was a psychiatrist at Glasgow University, and he kind of saw there was something in this. So we started putting in grant applications and trying to get support for this, and basically no one would listen to it. It was like, so a diet's going to fix your bipolar, cool, next. And that was the response for quite a long time, maybe like 3 or 4 years of people just sort of really being like, what on earth is this? And I tried to get fellowships and grant funding, and nothing really worked. But eventually, so I just kind of came to a point where I couldn't get any support to do scientific research on this, and I'd finished my PhD, and I was considering whether I want to go into research full time. So what I did was I made this YouTube video. It's still on YouTube. It's on an old channel called Keto Bipolar, and it's like this 45-minute YouTube video where I just put everything that I'd learned, like all like mitochondrial function, how this affects insulin resistance, how this links to medication. Everything's in that 45-minute video. Even like the papers that I'm still publishing now are generally coming out of that, things that I discussed in that video. And I put it online, and I put it on Twitter. It was my very first post on my Twitter account. You can find it. And I made the Twitter just because I thought, well, maybe I'll put it out there like a message in a bottle. Someone will pick it up and be able to do something with this when this is more well understood or something. Then Chris Palmer found it. I guess there wasn't many people tweeting about this at the time. And so Chris retweeted it, and I was like, wow, like I was saying to Becky, my wife, like a Harvard psychiatrist has just retweeted this video that I put up, which at the time seemed preposterous because nobody would have an interest in it. And then Jan Bazuki found it, who is the mother of Matt Bazuki, who has bipolar, and I didn't know, but he'd been through this experience. He had bipolar disorder, went on a ketogenic diet after trying like 30, 40 different treatments around the US healthcare system. Chris Palmer put him on a ketogenic diet, and he got completely well. And she sent us an email and said, would you like to meet and talk about maybe doing some research? And so we had this meeting, and I was like, oh my goodness, like, they want to support this research, and we might be able to do a study. And they funded us to do a pilot study. She's a philanthropist. And so they really, all of our research started from this meeting with Jan Bazuki, and she funded this pilot study, and we carried it out at Edinburgh University with 20 bipolar patients. And this is like a small pilot study, but we saw some really promising indications that this is helpful for people, not just me, but other people as well that we're working with. We saw changes in mood and energy that were positive, reductions in brain glutamate, which is a marker in bipolar of kind of excitotoxicity in the brain. And we saw significant improvements in their metabolic health at the same time. And so we're always modest about pilot studies, but it was exciting because this is actually potentially a new treatment for this condition, and so many of our participants, about a third of them, remained on the diet after the study, and continue, and I keep in touch with them to this day.
Yeah,
and many of them, and yeah, you can see Oliver Seligman, for example, Thriving with Bipolar. He has a YouTube channel where he describes his whole journey with it and how it's really changed the quality of his life. So we decided, okay, we will need to do larger research studies on this. And we then applied to and I guess this will be helpful for people who are coming into this field who want to get involved and are kind of looking for a way from it. You really just, whatever stage you're at, if you can do the very best thing you possibly can at that stage, it's amazing how you will find people and doors will open up. All I could do is make this 45-minute YouTube video. I thought no one might ever watch it. And it's funny how it made its way to the right people. So if you're kind of looking to be involved in this field, just find the thing that you're doing and do it as well as you possibly can, whether that's podcasting or making like keto products or doing research or, engaging with patients. Just do like the very best thing you can and put it out into the world and see, because I think you'll find support for it.
That's an amazing story, first of all, and how grateful I am that you persevered. And it brought me to tears because my aunt was bipolar, and I saw the struggle and how brilliant she was, and how our favorite family stories are about my aunt, right? Just a brilliant soul who also had type 2 diabetes and also clearly had this insulin resistant state, and it was too early. Like there wasn't this buzz around it yet. So and I lost 2 friends to suicide this year. And so it really means a lot to me, the work you're doing. And I want to back up for a minute because we're going to get to that trial and your other research. And the fact that you're a musician and a PhD researcher is insane. So I think it's safe to say keto diet changed your life in maybe every imaginable way. Could you say that's true?
Yeah, it allowed me to become a father, to work full time, to have like stable mood, quality of life that were just never possible for me. It was really the most helpful thing of anything that I've tried in my life with bipolar, and that's what I was always looking for, is something that would allow me to work. I still have bipolar disorder, and it's not always, living with a condition like that is always never easy, but it's given me this tool that allows me to live a quality of life where I can do everything that I would really want to be able to do in my life, and that's what I was always hoping for.
Yeah.
And so my kind of goal with research is to give that option to other people, to give them a tool that helps them to live a quality of life that they want to have and to contribute to the world they want to.
Yeah, and I was wondering, what were you eating before? Do you feel like insulin resistance was a contributing factor in your bipolar?
So it's not something that I'd ever considered, but the thing that really convinced me that this is something that I should pursue was that I was taking this MCTOL supplement. It was a CA-MCTOL, and that kind of puts you into ketosis quite quickly. And, I knew the diet was having some effect by this stage, but I could never be sure because there's so many factors in your life that are changing. But I started taking this CA-MCTOL, and I'd take it, and then within like half an hour, Becky, my wife, would say like, "Oh, you seem completely different from like half an hour ago or 45 minutes ago, just from taking this supplement. And to me that was, and I felt it, I really felt the depression lift in a very profound way just within 45 minutes of taking this. And I later learned that they use this in epilepsy treatment as a supplement to help with seizure. So I realized there's something about ketones themselves, like the ketone bodies, that helps with this. And then the more I read about that, the more I learned that they kind of bypass insulin-resistant pathways. So if you have insulin resistance, it doesn't just occur in the body, it occurs also in the brain. In the same way that ketones can bypass these insulin-resistant pathways in the body, they can also do this in the brain. And I think this is part of the reason they work, because the brain is kind of being starved of energy from glucose, and you have this mitochondrial dysfunction, and ketone bodies provide you an alternative fuel source. So there was a period of life where you could never find me without a flask with MCT and I was doing ketogenic diet and going around with a flask, and I was just happy for the first time. I was functional, I had energy, my mood was stable, and I was going around with this flask everywhere I went, and people would always make fun of me for being, physically attached to this flask. But it really did make such an incredible difference, and I still use that supplement to this day as a way to boost ketosis. But I think what I've learned since then is that it's really used in epilepsy as a treatment, as part of clinical trials, and care for epilepsy as an anti-seizure thing. So it's that was how I came to the idea of insulin resistance.
And I'm interested, we're going to get to the mechanisms, but talk about how long have we known that diet, carbohydrates, glucose metabolism has impacted brain function?
The major shift that's happened is that the brain was considered to be generally an insulin-independent organ. So in the kind of, maybe even back to the 1970s, it was considered that the brain didn't really use insulin in the same way as the rest of the body. Insulin wasn't as significant in the brain as it was in the peripheral tissues. And then we really, that has been completely eroded, that idea now that insulin is just as important in the brain as it is in the rest of the body. We found initially insulin receptors in the animal brain and in the human brain. And now we really have much more detailed studies on insulin signaling pathways in conditions like Alzheimer's and now in bipolar disorder, and showing that these insulin signaling pathways, which kind of, you can think of insulin signaling a little bit like the signal from the accelerator pedal to the engine. It's the kind of signal from your environment to tell the engines of your mitochondria and glucose metabolism, how to take up fuel and use fuel and burn fuel. And we see disruption of these pathways in bipolar and other neurological conditions. So that was one of the major shifts that happened, is showing that insulin is just as important in the brain as it is in the rest of the body.
And so do you think this is a subset of people? Like in bipolar, within the umbrella of bipolar, there are some people who might be insulin resistant and their glucose metabolism, mitochondrial function is impaired. Or do you think this has broad implications? What are your thoughts there?
Yeah, so I think there's obviously widespread metabolic dysfunction in the population. And the rates in the UK and the US that I'm familiar with are particularly bad in the kind of Western world with their modern diet. And so I think a lot of people are struggling with forms of insulin resistance in the brain that they're not aware of, and that if they were to make a change to fix that, they might experience significant improvements. For smaller percentages of the population, much smaller percentages of the population, they just have very, very severe, psychiatric symptoms like schizophrenia or bipolar. And I think these are people that are somewhat genetically susceptible to these conditions. And if you throw the same environment at that person, another person might absorb it, and handle it quite well. Whereas someone with these predispositions, it can completely break these systems in the body that are keeping you in balance. And so, I think that people with bipolar, it definitely runs in families, and so there's a kind of genetic component, but it's probably for many people the environment that really pushes them into having severe symptoms.
So you'd say food could potentially be a huge player in, not curing, managing. Do you think it could manage this for a lot of people if they were able to try a keto diet?
Yeah, so what we need to do now is we want to do a large RCTs to understand what percentage of people might be helped. But in epilepsy, it turns out that maybe a third of people will stop having seizures, a third will have significant improvements, and a third won't respond to it. And so there might be something like that in psychiatric conditions where you get these very strong responders and these people who are sort of in the middle and then don't respond. But I think it's quite promising, because in epilepsy, if you introduce it early enough, the thing that's most remarkable about ketogenic diet is it can completely reverse seizures. So all across the UK in hospitals, you can get this as a treatment for epilepsy as if you're a child. And it should be available to adults as well, but it just happens to be used in kids' epilepsy the most. And they can do it for 1 or 2 years, and a significant percent of them, maybe between 30 and 50%, will just stop having seizures and they won't come back. And isn't that remarkable?
It's
I met
crazy.
yeah,
Yeah.
I met someone this week who has epilepsy, and I told them, have you heard of ketogenic diet? And they'd never heard of it. They have a neurologist. They get checked up every 3 months or so, and they'd never heard of ketogenic diet. And it's one of the most high impact things you can actually do, in terms of helping someone. I feel is if you meet someone with epilepsy, tell them about ketogenic diet, because there's maybe like a 30 to 50% chance they could have a huge reduction in their seizures or some reduction in their seizures. So, I always mention this whenever I go to conferences. If you have epilepsy, you should definitely look into this, because many people just aren't aware of it, which I think is quite crazy, considering that it could be a cure for children with this condition.
Yeah, for 30 to 50%. I mean, if there were drugs that did that so consistently, I mean, everybody
Yeah.
would know about it.
So I think, like you're saying, in terms of like the population having insulin resistance and metabolic dysfunction, if you could offer something that would potentially reverse this and prevent them going down that road early in life, it's a really powerful early intervention and might prevent a lot of people getting this in the first place. So I really am supportive of like early intervention initiatives to reach young people with metabolic health advice, because ideally you just prevent them going down this road, like we've demonstrated that you absolutely can in epilepsy. And I think that might be possible in bipolar. I've heard from a very small number of patients who've said that they implemented this and their symptoms have never come back. There's people like Carrie Brown, who was a ketogenic diet advocate, and she essentially told us on our podcast that she's done this and her symptoms have never come back. And there's a couple other people I've spoken to who've also experienced that. So if that's possible, we should definitely be letting people know about it.
Yeah, and I want you to tell us, like, what would signs be that you are insulin resistant, and maybe in kids? Because what I was going to tell you is I keep my blood sugar. I've always, well, since my dietary transition, low carb is where I need to live. It is. And when I deviate, especially when I have large amounts of sugar, I feel predictably sad. Like,
Yeah.
my life doesn't matter. What am I even doing? Why would I even get up and do that stuff? Like, I'm not making a difference. I mean, the thoughts are, I don't know what it is. And I'm metabolically healthy. That's the thing. So it's like, is it just that we're overweight, that our insulin or fasting insulin is elevated, that our blood sugar is out of range? How would we know? Because I'm not those things, but yet it still remains. So what are the indicators? What are the symptoms? Like, how do we know this might apply to us?
Can I ask, we had the mood improvement when you changed your diet, was it immediate or did it take time? Or I'm interested.
Here's the thing. I changed my diet to a whole foods diet, and I still ate a lot of mango and fruits, always having fruit. And it was only when I started to go low carb that I was like, oh, wait, my mood. Like, I went from being up and down, and I'm sure I have the genetics. My aunt was bipolar, and I would crash, and I would have I'm so excited, and then I'm so sad, and I stabilized, and I thought, oh, what is this place? Just like you said, ripples of like happiness and stability, and I was like, this is a different experience. This is a different life entirely. So it was after low carb came into the picture too.
And if I can ask, did you measure ketosis at the time, or were you just focused mainly on reducing carbohydrate?
Yeah, so what I did is I have measured my ketones. I don't ever get very high above 1. And so I kind of live at like 0.5. I don't measure them all the time because I know I've been doing this for like 10 years now. So I just know what I can eat and what I can't. And I know the next day, if I go on vacation and I indulge, I might feel a little sad, but I know that's not really my thoughts about my life. That's my metabolism. So, but I would love to know, like, what do you think? I know in your trial, there was like ketones over 2. Why don't you just break down your trial? Tell us what you saw. Take us there.
Yeah, so, and I'll circle back to your question about how you would measure insulin resistance.
Oh, no, start there and then go into your trial.
And
then go to your trial.
Yes. So insulin resistance is kind of typically measured by HOMA-IR or C-peptide measures, and it's quite difficult for people to get access to these. If you go to your GP in the UK, they typically won't give you a HOMA-IR assessment, and so it's not always easy to find out your HOMA-IR. Even in clinical trials, it can be kind of expensive to measure, and people don't tend to include it. I think it's a helpful indicator of metabolic health, but it's not a perfect one for many different reasons, but it is an indicator of insulin resistance. There's other kind of more sophisticated measures that you can use in clinical research, but they tend to be more expensive and difficult. But HOMA-IR is quite a good place to start. If you can get that measured, you can get it through private blood tests. We don't yet fully understand how this relates to psychiatric symptoms or progression of psychiatric symptoms, there's very strong indicators that insulin resistance leads to psychiatric symptoms. In young people, for example, it's a very significant risk factor. There's tools like, I think it's called SciMet which measures the risk of developing a psychiatric condition, and insulin resistance is one of the most predictive factors for that. And it definitely makes people have worse course of illness. They have like a more severe course of illness if they have insulin resistance. But it's not clear that just having insulin resistance is going to tell you whether this is the cause of your psychiatric condition. There's probably multiple causes that lead to this metabolic and energy disruption in the brain, and one of them can be this kind of environmental pressure from food and insulin resistance, but there can also be stress and light. Circadian management is a huge thing in bipolar disorder. There's seasonal variation of symptoms, but I think ultimately downstream of all these things is this metabolic dysregulation in the brain. And this is something that's been recognized in psychiatry for a very long time. Emil Kraepelin was considered the founder of modern psychiatry, and in 1921 he wrote that marked disorders of metabolism must be taking place in these conditions from his clinical observations. And this was 100 years ago, a psychiatrist saying this. The person who developed the very first psychiatric medication was called Henri Labouré, and his textbooks are called the regulation of metabolism, aspects of metabolism in pharmacology. He saw all psychiatric conditions as being fundamentally disorders of metabolism in the brain. He was writing in, I guess, the 1960s. He developed the very first medication, chlorpromazine, for psychiatric use, and he said the whole theoretical basis he had for developing this was a dysregulation of metabolism in the brain, and very few people are even aware of this. You can't even find his books anymore. I had to order them in from another university, and it took weeks to find them. But another remarkable thing about that is he actually developed a treatment called 4-hydroxybutyrate, which is very similar to 3-hydroxybutyrate, beta-hydroxybutyrate that we generate in ketosis. He actually developed 4-hydroxybutyrate as a treatment for mental illness in the 1960s. So the very first person to develop psychiatric medications was almost like developing a ketone body. Essentially he was for treatment of patients, and this got lost to history. There's a lot of characterizations he gives of mental illness that I now agree with from a scientific perspective, back in the 1960s. So I could share some of those if you like, but I'll get to the trial as well. I don't know.
Well, that's crazy to me. I was a child on SSRIs, and I know that kind of in the 1960s kind of just turned, we went serotonin and we started norepinephrine. So take us, your paper, you have this kind of metabolic basis. We're talking about glutamate, we're talking about glycolysis and oxidative phosphorylation. Yep. Can you tell us about those mechanisms, and then what happened when SSRIs came into the picture?
Henri Labouré, he was he was this incredible figure in the 1960s. He was a real kind of renegade scientist. He self-funded a lot of his own research by patenting pharmaceuticals that he made at the time, but then researching his lab, the kind of fundamental mechanisms. He was really obsessive about understanding all the different mechanisms that contribute to these conditions. But he also was a playwright, and he did a lot of creative things. A really interesting person. But essentially what he came to was, he said there's these psychiatric conditions are disorders of metabolism in the brain. They're disorders of energy in the brain, and they have certain characteristics. And the first distinction he made is that we only focus on neurons in psychiatric research. And he said what these really are is a disturbance between astrocytes and neurons, because astrocytes are what provide energy to neurons. Mm-hmm. So astrocytes are the support network around the neuron that provide energy and metabolic substrates to make energy with. So he said we've been focused all this time just on neurons, and really what we need to look at is the energy infrastructure of the brain, the power grid of the brain, which is astrocytes. And he said that astrocytes are feeding energy molecules, metabolites, to neurons, and this becomes disrupted in psychiatric conditions. So the second thing he said is, you mentioned glycolysis and oxidative phosphorylation. He said that in the mitochondria, oxidative phosphorylation kind of become inhibited, but it can also, glycolysis and oxidative phosphorylation can go into overdrive. So he saw mania and psychosis and these symptoms as a form of kind of metabolic overdrive in the brain. It's like putting on the gas pedal on the brain all the way up, and people didn't know how to manage this. And he said that you can also have impairment of metabolism, and this results in depression and other states. And so he said the reason this happens is because in the modern world that we live in, we have these kind of capacities, and people sometimes have a sense for this, that you have a capacity to go in very heightened states of activation when you need to. If someone's in trouble, you need to help them if you have an emergency. And then you also have this capacity to go in states of energy conservation, where in the winter, humans are kind of conserving energy and dialing down their activity sometimes, less so with artificial light now. But this is a feature of the natural world. Animals are always trying to optimize and conserve energy through suppressing their energy, going into torpor, hibernation, and then ramping up their energy for survival activities like hunting and all these kind of things that happen in the spring. And in bipolar, you see this seasonality very clearly. It's in the spring you get this huge uptick in mania, hospitalizations, and in the winter you get this very significant uptick in depression, hospitalizations. And so he saw it as kind of like an evolutionary mismatch where in our natural environment we'd have all kinds of reasons, in a kind of Paleolithic environment to be hunting and upregulating our energy and exploring and finding new horizons. And if you're sitting in an office with artificial lighting, 9 to 5, and you're having these huge surges in your metabolism and creativity and, pattern recognition, it can really be confusing for people, what is the purpose of this? And similarly, if you're in the winter with someone with bipolar and you're going into this severe depression and you can't leave your room, you can't move, you're going into kind of like a state of energy conservation. So he saw this as a kind of mismatch between these two states. And I only came to read his work more recently, but I'd come to almost these kind of same conclusions through just my own reasoning about ketosis and metabolism. And I was amazed that, this is the very founder of psychiatry and he saw it in this way. So yeah, I think that there's these kind of states that humans can go into that had an evolutionary purpose, but they become completely broken and dysregulated in our modern environment and can really throw people into confusion. Perhaps there was a reason for some of these things, and there was a healthy version of them that we used to experience. But in the modern world, we get very dysregulated versions of them.
Yeah, I love that. I mean, they're persisting. These genes are persisting in the population, and obviously there's a lot of artists and people who contribute so meaningfully, right, to our society. Yeah. And also, can you, just for people who are new to this idea, so the brain can function on glucose and ketone bodies. It's kind of like a hybrid engine. And glycolysis and oxidative phosphorylation are different ways to process glucose. Can you just break that down for a layperson? Like, what is going into ketosis doing for people? Why is it important?
So if you think of your brain a bit like a kind of hybrid engine, and you imagine you have this kind of diesel engine, which is glucose, and you have this kind of hybrid electric engine, which is ketones. If you have your diesel engine kind of sputtering, sometimes the gas is all the way on and sometimes it's off, you're having mania and depression, it might make sense to try and switch over to this alternative engine, this electric engine, which would be like ketones. And so you're switching out this fuel source. Laborie felt that basically what happens in mania is there's just this really strong dysregulation of glucose metabolism. Sometimes it's all the way on, sometimes it's kind of switched off. And then in ketosis, you're kind of switching to this completely separate system where you can provide this stable fuel source for the brain. And this could alleviate mood symptoms for people. So in epilepsy, we think part of the reason it works is because of this. The glucose metabolism is heavily dysregulated and the ketone bodies provide an alternative energy source for this. And I think this kind of makes sense. When you live with a mental health condition, it kind of feels like you're driving down the highway and, everything is on fire. It's like, there's the car is filling up with smoke. There's clearly like some physiological emergency with your body and your brain, but it's hard to understand what it is. And I was put on SSRIs as well. And really, to me, SSRIs felt like in that situation, you're really just like fiddling with the air conditioning. It doesn't feel like a fundamental fix. It feels like you're just kind of trying to make it a bit more bearable, get some smoke out of the car. You're not really fixing it. It's just making it perhaps slightly more manageable. Whereas if you were to really fix the fundamental problem, which is that your engine is on fire, the engine is on fire and it's filling up, it would fix all these other downstream problems. You wouldn't have to be worrying about the air conditioning or anything else. You just fix the fundamental energy problem. So in that analogy, switching over to the hybrid electric engine of ketones is a potential solution, yeah.
Yeah, I love that. And that's right. SSRIs, I know for some people they're life changing, but for me, it just felt like it turned down the volume on everything. Like I was no longer myself and I couldn't experience heightened states of joy whenever I had access to them before, so yeah, and I know that SSRIs came in and kind of took over. But glutamate is also something you've talked a lot about. So is glutamate a neurotransmitter that we should be paying more attention to? And is it applicable? Is it important in disorders beyond bipolar, do you think?
I love this topic. So, the whole industry of mental health treatment was kind of predicated on research in serotonin, dopamine, those are two major focuses. But if you actually look at the concentrations of these neurotransmitters in the brain, they're in tiny concentrations, serotonin and dopamine, compared to glutamate. Like, if you were to sort of take a bathtub and fill it up with the relative proportions, you'd find these neurotransmitters in the brain. You would be pouring in like gallons of glutamate all the way to the top of the bathtub. And if you were to take the kind of comparative amount of serotonin and dopamine that exists in your brain. I'm sorry for how imprecise this is, but it is a helpful way of visualizing it. You know, you'd be filling up the bathtub right to the brim with glutamate, and you take a little toothpaste cap, you know, like 30 milliliters of serotonin and dopamine. That's how much serotonin and dopamine exists in the brain. You know, and we've based the whole treatment of mental health on modulating these neurotransmitters, whereas there's this ocean of glutamate that's flooding your brain, managing energy. It's incredibly influential for energy metabolism in the brain because it also acts as an energy metabolite in the brain. It's not just a neurotransmitter. You know, if you were just looking from the outside, you'd say like, well, surely we should do something with glutamate. You know, this seems important. You know, if you were, you know, it seems it's such in such large concentrations. It participates in energy metabolism. And about 80, you know, it's been estimated that about 80% of the brain's energy is dedicated to glutamatergic neurotransmission. So glutamate accounts for about 80% of what your brain energy is being utilized for. So, you know, if you were thinking about fixing mental health and you believe it's a metabolic problem, glutamate would be the absolute first place you might want to look to do research. But the problem is every time they've tried to develop treatments that affect the glutamate system, that they result in severe side effects, seizures, all kinds of neurological problems. So it's been really difficult to develop any medication for it. So in the kind of 1960s, 1980s, it made much more sense from a business perspective, in my opinion, to just modulate serotonin, dopamine, the things that are less consequential. Mm-hmm. And they might have less side effects, but they also probably are just much less influential on changing your mental health because of that. But you know, you're not going to have a seizure modulating those things in the same way, but you might also not have much difference to your motor function. I mean, this is not to say that dopamine isn't incredibly important for mental health. It is, but there's a different category of you know, effects in the brain with glutamate. It's a very influential molecule. So what was interesting was in our pilot study we did brain imaging to measure this. The first thing we saw when people's ketone level went up, we saw a correlation with improvements in their mood and energy and reductions in their anxiety. We measured it every day, their ketone level and their mood symptoms. And you can see some interviews on Metabolic Mind with patients from a trial describing what this was like. And some of the people that remain on the diet found this to be a really life-changing intervention. I actually ran into one of them on the bus the other day, and it was really wonderful. He was just like glowing, like really enjoying his life, thriving, and it was really wonderful to see. But we actually looked in the brain to see what was changing, and we saw that glutamate levels decreased quite significantly, about sort of 11 or 13%, which is compared to, you know, studies with anti-epileptic medications, they would typically see like a 6% reduction, you know, as the most on a kind of significant anti-seizure medication like lamotrigine. And we saw 11 or 13% reductions just with 8 weeks on a ketogenic diet. So we were like, you know, what's happened here? And I have a paper in Nature Molecular Psychiatry about this called the Metabolic Overdrive Hypothesis. And I think that one of the things that's happening is that it was just what I was trying to describe about glutamate is that it's not just a neurotransmitter, it's also a fuel source in the brain, and it participates in energy. You know, it's like I say, it's about 80% of the brain's energy is used for glutamatergic neurotransmission. So if you have metabolic disruption in the brain, it's inherently tied to glutamate dysfunction in the brain. And I think that's why we should be researching this. And when we saw these reductions in glutamate, we realized this is an area that we want to explore a lot further to try and understand. I personally think it's one of the mechanisms of action of ketosis is that it restores energy metabolism in the brain, which rebalances the glutamate system. So we'll have some news to announce actually next month about how we're going to look more into this. But to me, it's just an obvious thing that's been overlooked. It's the, you know, one of them. It's the most abundant neurotransmitter in the brain. It has a huge effect on energy metabolism. It's shown to be dysregulated between epilepsy and bipolar and across psychiatric conditions. So why do we not have medications that treat glutamate dysfunction? And I think it's for the reasons that I gave, that it wasn't feasible as a kind of business proposal at the time.
Yeah, so what I'm hearing is that diet can kind of rebalance the brain in a way that we haven't yet been able to figure out with drug therapy, right?
Well, that's essentially what we saw. The only way we know of to change glutamate in the brain is with epilepsy medications, and they reduce glutamate. And we saw larger reductions in 8 weeks of ketogenic diet. Again, it's in a pilot study and we need to do this in larger numbers, but this was really interesting to observe. And I couldn't actually find any other studies with that level of reduction of glutamate. There might be out there, but it was very difficult to find any seizure medication trials that show that level of reduction of glutamate. So I think that, you know, this is one of the first indications we have that there's a real physical change in the brain that's meaningful for these conditions, and we're going to do a lot more research on this.
So just for anyone who's new to this too, a pilot trial is kind of like we're going to see if this is worth exploring more deeply. And you had 20 participants, and I think they were relatively stable, right? at this point in time. And then they had positive associations, meaning the higher the blood ketone levels with impulsivity in mood, so they were better able to control their impulses. They had higher levels of mood, higher levels of energy, and lower levels of anxiety. Correct me if I'm wrong on that. But the other cool part is that their metabolic health improved. And this usually is the opposite with meds. Usually metabolic health goes down or people gain weight, which can be so life-changing. Can you talk about that aspect too?
Yeah, so we saw significant weight reductions, 4.7 kilograms weight reduction just over 8 weeks on average. But what was most remarkable about this is that they were on medications, many of them that typically result in weight gain, and really it's really difficult to lose weight. And when we talk about like psychiatric medications, there's things like, the kind of classic examples would be like olanzapine. That is a very common medication that people get put on with mania. And when you take olanzapine or these kind of medications, you can put on quite a significant amount of weight. This is really well understood in the science literature. Even like 20 or 30 pounds in a few weeks of taking them. And it can be really devastating, particularly for young people, for their self-esteem to be put on a medication and not understand that this is going to happen to them and then have it happen. And then all the things that come with that. So it's a real problem in psychiatry that it keeps people out of hospital. And so there's value in these medications. They can prevent mania. They can bring down psychosis. But really, all of these medications came from Henry Laborie, who I described. He developed the very first antipsychotic called chlorpromazine. And all of the subsequent medications essentially came out of, directly or indirectly from his initial application of chlorpromazine to psychiatry. And he said the way this medication works is it turns down hypermetabolic states in the brain. It turns down these like overdrive, high energy states in the brain. But then we kind of, in the 1960s, 70s, we went on this neurotransmitter kind of thing where we understood everything is neurotransmitted. But if you look at the originator of this whole field, he said, no, what these medications do is they turn down hypermetabolic states in the brain. And he described in quite a lot of detail how he thinks this occurs. And essentially he felt that in the mitochondria, there was states of kind of real overdrive in the brain happening, this metabolic dysregulation. And what these medications do is they block specific parts of the mitochondrial function to bring down those states of metabolic overdrive and let someone stabilize. So his intention for these medications was you deliver them to someone who's in psychosis or mania, let them get back down to their baseline state, and then you take them off of it and use other therapies and health to maintain their health. He never intended it as like a long-term solution for these conditions. But what we do now is we use them for months and years at a time, and people continue to have declines in their metabolic health. I think they are very valuable tools in those acute scenarios. They can bring someone out of a state and they can be really life-saving, and that was Henri Laborie's intention for them. But when you just give them chronically and there's no effort to improve metabolic health in other means, it can lead people into real metabolic decline, which is really unfortunate. And I've seen it many times in patients. It's quite tragic to see. So I think there's a healthy interaction between diet and medication, and that we can find where if someone's really in an emergency, what a great thing to give them a life-saving intervention. But for long-term management of their health, they should be engaging with diet, exercise, improving metabolic health over the long term, which will hopefully mean they have to use these less often as well.
Yeah. So would you say, because it seems like addressing mitochondrial health, that is at the heart of what we need to do. We have to keep those mitochondria healthy. Now, is that downstream of insulin resistance comes in and impairs mitochondrial health? And so is addressing insulin resistance addressing mitochondrial health? Or like when you get to the heart of it, if you put these people on medication, stabilize them, what then would you be having people do? A keto diet, obviously. Anything else? Or what do you think? What are your thoughts on that?
So you could think of like insulin resistance, and you could think of the mitochondria as like the engine in the brain that is kind of driving energy. It does many, many, many more things than that. Martin Picard is a great source of information on how many wonderful things mitochondria do. One of the functions is to provide energy to the brain. And then you could think of kind of insulin signaling as like the signal from the accelerator to the engine. It's telling the engine when to burn fuel, when to uptake fuel, how much to go. And so if you have a kind of break between those two systems, between insulin resistance, you can get impaired mitochondrial function because the mitochondria are not receiving those signals of, the cell's not receiving those signals of how to uptake glucose and burn it in the mitochondria at the right rates and at the right times. So you get this kind of systemic dysregulation. So you want to manage this at multiple levels. One kind of fundamental solution that we've been describing is replacing the fuel source using this hybrid engine, the ketone system, giving an alternative energy source to the mitochondria. And they burn with like 32% more ATP. They're a very efficient energy fuel source for the mitochondria, ketones. So that's one way you can kind of bypass this energy problem. But another way you can do it is to regulate the upstream signaling that goes to your mitochondria, so you can give it inputs to your circadian systems, for example, that help you regulate your metabolism properly. So when you get light in your eyes, the light comes through your retina and it goes to this part of the brain called the suprachiasmatic nucleus, and that the SCN, the suprachiasmatic nucleus, sends signals to your whole metabolic system all over your body into all different places of how to regulate your metabolic function. So when you get good light exposure, like you get light exposure in the morning, it signals to your whole metabolic system to ramp up energy production and go into an active mode. And when you get a sunset, when you view a sunset and you get that kind of dark at nighttime, you're signaling through your SCN to your whole metabolic system, now's the time to conserve energy and rest. That's another regulator of metabolism. And this also happens seasonally. Your body is like so finely attuned to the seasonal changes in light environment. It can actually detect, when the equinoxes are occurring. Many people don't know this, but you can look at, there's really interesting studies of gene expression in humans, and you can see a very clear seasonal pattern in your metabolic gene expression. So during this, around the spring equinox, you have this real uptick in your kind of energy, and your metabolic system is tuning up, and then around the kind of autumn equinox, you get, around the kind of winter solstice, you get a kind of a turning down of these metabolic mechanisms in the mRNA expression. So, these are real biological changes that sync up with these, I always joke that the only people paying attention to the solstices and equinoxes are like people with bipolar and pagans. There's nobody else in between. It's really like it's a niche topic. But a lot of my friends with bipolar are tracking the equinoxes because they know that these are the times they're going to go manic, because there's such a quick shift in the light environment that your metabolic systems get the signal through the SCN and they start to dysregulate because they're sensing a very quick change in the environment. Again, you can give evolutionary analogies for this. There's some really interesting ones. Like there's one that was published about in the early 1920s. It's called Zagunru, and it's what happens to birds in captivity who are migratory. And if you follow them throughout the spring equinox, at the same time you get this rapid rise in hospitalizations of mania. These birds, they start flapping their wings all night, they're banging their head off the cage, they're actually orientating themselves north, trying to fulfill this kind of migration behavior that's programmed into their biology. And so they would appear to any observer to be insane. They were trying to understand, why does this happen? They're flapping their wings, they're banging their head off the cage, they're trying to escape, they're up all night, insomnia. And what's happening is that their body is telling them to go into a hypermetabolic state in response to the spring equinox, this changing of light environment. But if you took a human who was experiencing that and they're working in an office environment, and this ancient survival program starts kicking in to go hunting, or find a new place for your family to live, cross an ice bridge somewhere in the in previous times, you would be considered insane. And similarly in the winter, if you were to have very severe energy deprivation and conservation, that was a kind of dysfunctional version of this kind of natural energy conservation that happens in all biological life, you might be considered to be depressed. But for modern humans, we're kind of living in this environment where we're not out in nature, we're not getting these signals and seeing the purpose of these things, and so we get very, very dysregulated versions of them that can seem like insanity if you don't understand where it's coming from.
Yeah, but there was an evolutionary advantage. I love this highly sensitive person. People are just attuned to different things, responding to different things. And maybe this is a way to kind of help people manage better. Would you say that then? Are we healing a brain, or are we helping people manage better in the current environment?
So I think that people think of ketogenic diet as like this fad diet, or this modern kind of like innovation, something that you would get a snack bar for in a I guess it's like CVS in America, and they have them in the supermarkets here. But really what ketogenic diet is, it's inducing a state of ketosis, which is a really ancient biological state which has been around for hundreds of thousands, actually millions of years in our evolution. I think the gene for ketosis evolved maybe 450 million years ago, a very, very, very long time back in our biology. Ketosis emerged as a mechanism that was used by all life. So to say that ketogenic diet is this modern fad intervention, it's missing the point of no, we're talking about really fundamental aspects of our biology that go back to our ancient history, and most life was going through periods of ketosis yearly, usually with seasonal cycles. You can think of the most extreme example of animals hibernating and using their fat reserves for energy. They would be going into ketosis for long periods. You can think of people kind of hunting and relying on their fat reserves as they travel long distances. And even just with the availability of carbohydrates, it changes throughout the year. So really people should be in a evolutionary consistent environment, going through periods of ketosis throughout the year. And another reason for ketosis was it was in response to stressors. So if you had an illness or an infection that you couldn't deal with, your hunger goes to nothing. You experience this, and even now when you get ill, your hunger can turn off for a period of time, and it's because your body's expecting to go into ketosis and rely on your fat reserves. And this was just an ancient survival mechanism. It's because you can carry like 2,000 calories of sugar, glycogen in your liver, but you can carry over 100,000 calories of fat on your body. So which is the more important survival fuel, this 2,000 calorie supply you have in your liver, or the over 100,000 calories that you can carry on your body as fat? Clearly the fat reserves are much more important for survival in the long term, and your body would have all these mechanisms to draw on those reserves when you're ill, when there's seasonal changes, when there's stressors, when there's hunting, all these evolutionary signals that we would get to use ketosis and fat metabolism. So yeah, I think that basically, to answer your question, we're kind of humans that have kind of we're beautifully designed for a world that we no longer live in. So yeah. We're trying to we've got these incredible survival metabolic mechanisms, but they're really finding a mismatch with the environment that we live in, and they're so incredibly intricate and well designed to keep us alive and to make us thrive. But if we give them incongruous signals like artificial light environment, artificial food environment, our biology has never seen this in its whole evolutionary history, and it just dysregulates. It doesn't know what to do with it. So I think we're kind of like finding our way back home in a way to our evolutionary kind of roots and what we're really looking for in nature, and to have kind of really thriving instead of just getting by.
Oh my gosh, so beautifully stated. Do you have time for just two more things? I want to know what a day in your diet looks like, and do you have to stay on this diet to maintain your results? And then do you think this applies to other mental health conditions? And then where's your research going?
So I do have to stay in ketosis to maintain the benefits of it. And if I go out of it, I can notice symptoms come back. Not always immediately, but within 2 days, I can tend to notice things, particularly depression symptoms. So I unfortunately, I've tried many times to find a way to come out of ketosis and maintain the benefit, but I just have to stay. And this is similar to many people with epilepsy. They just have to remain on it to not have seizure.
Can you use exogenous ketones to keep you in there, or do you have to maintain the diet?
I can, yeah. So on days that I haven't been able to, I would use exogenous ketones, and they definitely help. It's not as good as the full diet, but they definitely help. And they've been a really helpful tool for me, particularly the kind of C8 MCTOs that I use. I've had difficult experiences with some esters, but C8 and MCTOs have been very helpful for me. And so the future of research is we have set up a hub for metabolic psychiatry at Emory University. We applied to the UK government, which is the kind of Medical Research Council, which is the largest funder of medical research in the UK. And we applied to this scheme that's it's like the hardest scheme to get. We spent so many years not getting grants and getting turned down for everything. We thought, let's just go for the hardest one. Let's go for the best one, and we'll see what we can do. And we'll see what happens. And each university only gets one application, and all the universities in the UK put their best application from the university, and then they choose 5 out of those to fund. And so we thought our chances are extremely slim with this completely new topic. But one thing we did is we got a lot of patient testimonials, and I tried to show like how many patients are having remarkable benefits from this and the promise of it. And I recorded testimonial videos, and we made short films out of them with music and everything, and tried to really like describe this is so important to patients. There's people really having life-changing transformations with this. And we played those, and I think many things came into an incredible team. And but I think some of the patient experience helped it to get funded. So we were funded for 5 years to set up a centre at Edinburgh for metabolic psychiatry, and we now have 5 UK universities as part of this hub for metabolic psychiatry. So we're doing loads of research across clinical trials, patient research, PhDs, master's students. It's really like this incredible engine of metabolic research happening in psychiatry. And next month we're going to announce something really exciting that we're going to do, which we think could really change this field and make it available to a lot more people. So next month we'll have some news, and I'll be sure to share with you as soon as it's gone public. But so yeah, we're really excited about doing much larger research and trying to get this out to as many people as it can help as possible.
Wow. I just can't even, I am just blown away by your story and what you've accomplished, and that you're bringing in your music and your research and it's like, it's insane. It's mind blowing. So just tell people where they can connect with you if they want to hear more about your research. And of course, we'll post all the links in the description.
I'm on Twitter, Ian Campbell, PhD, You can find Hub for Metabolic Psychiatry at hubformetabolicpsychiatry.com. If you're interested in my music, it's Ex Machina, EXMAKINA, where I've just released 3 new songs actually recently. And yeah, that's all.
Okay, thank you, Dr. Ian Campbell. I didn't even know you were a musician, so I can't wait to dig in. And I just think your work, like I said, it's life-changing. This has been life-changing for me. I wish my aunt had met you, but I know many people will be so glad they did, even if it wasn't her. So thank you for everything.
It's great to talk to you. Thank you for your time.